So continuing our adventures on naming alkenes and alkynes, we're going to deal with this compound here. So we're going to see that we've got two double bonds on it. And if we count the carbons, we have 1, 2, 3, 4, 5, 6 carbons. So we're starting with a base chain that is hexane. We know that we have double bonds in it, so this hexane will turn into hexene. And there's two double bonds, so we're actually going to turn this into hexadiene in order to get this correct. We also need to know then where the double bonds are actually starting, which side we're starting from. So if we start from this carbon, 1, 2 in, we'll have a double bond that starts at the 2 position, then 3, 4, 5. So we'll have a 3, 5 hexadiene. And if we start from the other side, we're going to have a 1. The double bond starts at the 1, 2, 3, 4. So we have a 1, 4. Those are lower numbers, so we're actually looking for the 1,4 system to do the job. So we will start then the naming from this side as number 1 carbon. And I will start to call this a hexa, and it's a 1,4-diene. So the last thing we need to look at then is stereochemistry. This double bond on the end here has two atoms that are the exact same, so they have the same atomic number, so there is no stereochemistry associated in the number 1 carbon, but the number 4 carbon does have stereochemistry associated with it, and so we're going to deal with the hydrogens on opposite sides. I've got a carbon up here, so this is going to be a number 1, this is going to be a 2, this is going to be a 1, this is going to be a 2. So if you don't understand what I'm saying, please watch my video on the E and Z naming to understand this numbering system that I'm going through. The numbers here are not on the... I just did it wrong too. Maybe I gotta go back and watch the video. That's a 1 and that's a 2. So the carbons are not on the same side, they're not on the same side. This is an E conformation. So out front here, I'm going to put a 4E. Hexa 1,4-diene. So the hexa is 6 carbons. There is a diene, so there's 2 double bonds. We know they're in the 1 and the 4 position, and as well, the 4 position actually has an E conformation on it. So we're going to continue naming some alkenes here, starting with this compound in the middle. So it's quite a complicated molecule. If we count the carbon chains, I'm going to circle it first, make sure we get everything. But we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbons. So we're starting with a decane. We know that there's double bonds in here, so the decane will turn into a decene. And in fact, we know that there's 1, 2, 3, 4 double bonds. So this will be a decatetraene. The problem is now we don't know where the double bonds are. Do we start from this side or do we start from this side? Also, there is an ethyl group hanging off, and we have to figure out where that is. And we're going to try having the lowest numbers possible when we do this. So let's erase all this stuff and start over. So if we start from this carbon here, we see we've got a double bond in the 1 position. If we're to start from this side, the double bond is in the 1 position, so that doesn't help us out. If we start further in, 1, 2, 3, we have a double bond at the 3 position. Over here, 1, 2, 3, there is no double bond. So this side is going to win out just based on the double bonds. As well, the ethyl group here, 1, 2, 3, 4, 5 in, 1, 2, 3, 4, 5, 6. Although this isn't the deciding factor, if these double bonds were a little more symmetric, say the double bond was here, the ethyl group here would be the deciding factor on which side we start from. So that would mean then that my double bonds are starting in the 1 position, the 3 position, the 6 position, and the 9 position. And the ethyl group here is in the 5 position. So now to completely draw this out, or write it out, I've got a 5 ethyl deca 1, 3, 6, 9 tetraene. The only thing missing from this now is stereochemistry. I know that I've got 4 double bonds, and we're going to check and make sure to see if there's any stereochemistry. The 2 at the end here, both of these have CH2s, and if you're not familiar with E and Z naming, please go back and look at my video on E and Z naming. But I have 2 hydrogens on the same carbon, so there's no higher atomic number on for each one of those. So there is no E and Z naming for the number 1 carbon and the number 9 carbon. There's no E and Z. However, the 3 position and the 6 position, there is an E or Z name, and we're going to go through that. So for the 3 position, we have to note that we still have hydrogens implied on these carbons. The hydrogens are not on the same side, they're not on the same side. The carbons here are on opposite sides, so if I were to write them out, the carbon gets a higher priority of 1, and the hydrogen gets a lower priority, and I'm going to call it number 2. This carbon gets a 1, this hydrogen gets a 2. They're on opposite sides of each other, they're not on the same side, so this is an E conformation. So we have a 3E conformation on that. And when we look at the 6th position here, the hydrogen's down here, the hydrogen's up here like this. Again, the hydrogens are on opposite sides, the carbons are on opposite sides, they're not on the same side. So the 6th carbon is in the E position as well. I don't have room to finish writing this, so I'm going to rewrite the entire name of this. So I'm going to put a 3E, 3E, 6E, dash 5 ethyl. Hope I leave room. Deca 1, 3, 6, 9 dash tetraene. Whew. And there we go. Let's continue our naming adventure with the compound seen here. Very similar to the previous one that we just did. So if we were to count the carbons, I'm going to draw a blob around my longest chain. And if I were to count the carbons, we would see that we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So again, we have a decane. The difference between the previous compound and this one is we're now seeing an alkyne. So we've got this triple bond in here, as well as the double bonds, and still an ethyl group here. So taking all of that in mind, we're going to start naming this. So we're trying to figure out what carbon we're going to start the numbering from. And since we have a combination of functional groups, we need to figure out what's higher priority. And since we have both triple bonds and double bonds on the same molecule, and they're the highest priority, when it comes to these two, the double bond is now the higher priority. So I'm going to neglect the fact that we've got alkynes now and just go straight to the double bonds. So if I go 1, 2, 3 in on this side, 1, 2, 3, 4 in on this side's going to win. This is the number 1 carbon because I'll get the lowest starting number on the highest priority group, which is the alkene. So then I know this is the 1 carbon, and so on the 1 position I have an alkyne, on the 3 position I have an alkene, on the 6 position I have an alkene, and on the 9 position I have an alkyne. So if we're to kind of write this out without the ethyl group, so I have a deca, and the ene comes first alphabetically. So I said that was in the 3, 6 position. That is a diene. And then I'm going to put E on the end of that one. And then in the 1 and the 9 position is the diene. Now the reason why I put the E here is because we're starting off with a D over here. If it was a vowel over here, I would get rid of the E. So it's really more of a vocabulary thing or a spelling thing that's involved in this more than anything. So now that I've got this, I still have this ethyl group and it's in the 5 position. So over here I'm going to put that there's a 5 ethyl. And it's quite a large molecule here. I'm going to have to rewrite it again or put it nicely on the screen for you. The last thing then, there's no stereochemistry associated with the alkynes, but with the double bonds there is stereochemistry, and we need to deal with that. So in the 3 and the 6 position, we have to dictate or indicate what is the stereochemistry of that. So I'm going to clean this up a bit so I can draw that out. So in the 3 position, I have to recognize I've got a hydrogen on each end of the double bond. They are on opposite sides. The carbons here are on opposite sides. So if we're to start with this carbon, I'm going to have a carbon that is atomic number that is higher than the hydrogen, so I'll give it a 1 and a 2. And on this side here, I have a carbon that's a 1 and a hydrogen that's a 2 as well. They're not on the same side, they're on opposite sides. So this is an E. So I have a 3E conformation here, and in the 6th position, we'll find it's the same. I've got the hydrogen hanging here like this, the hydrogen hanging off here as well. And so this is also an E conformation. So it's a 6E conformation. So out front here, I will have to put in a 3E, 6E, looks like a 6 and a 5, dash. So I'm going to rewrite this nicely for you below so that you can see what the real, what it really looks like. But we've got everything associated here, starting with the deca. So this is our 10 carbon chain that we've got. We have a diene, so we've got 2 double bonds, one in the 3 position, one in the 6. So the 3 and then the 6. We have a diene, so in the 1 position over here, and in the 9 position we have the diene. In the 5 position, we have the ethyl group, and then not only that, but then now the stereochemistry of the double bonds have been taken care of, noting that they're both in the E position.